Hey, hi, how are you guys? Hope you all are doing good. And today I'm going to start SHM, Simple Harmonic Motion. In this topic, I'm going to discuss exclusively the NEET and JEE level questions as well as theory. The most important part is to understand the theory behind this chapter, right? So, whatever possible questions can be framed and whatever question came in NEET and JEE already, we're going to discuss in detail in this video. So let's proceed with this. It will be a series of videos. This is just first video of SHM, then the second will come and third will come. So keep watching all these videos and definitely you'll get benefited. And it's not let me introduce myself. My name is Arshad Hussain and I'm physics faculty of an academy, senior physics faculty. I worked in Vedantu as a lead master teacher, and I worked in Super 50 also, a senior physics faculty there. So yeah, I have a lot of experience in JEE and NEET section. So yeah, definitely based on my experience, I will suggest you which part is more important, which part is less important. So let's go with the basic first. So first basic topic is periodic motion, right? So what is periodic motion, sir? So periodic motion is if an object repeats its motion after a fixed interval of time is called periodic motion. So if we'll talk about periodic motion, any motion, sir, let's say the needle of clock repeats after a fixed interval of time, right? If you will see the minute hand or hour hand or second hand, so all of them are repeating after a fixed interval of time, right? Similarly, if you will talk about the simple pendulum oscillating about a fixed point, this is also repeating its motion after fixed interval of time. The motion of planet about sun, planet about sun, right? So all these are periodic motion, right? After a fixed interval of time they are repeating these motions. Yeah, so you got the idea of periodic motion. Now coming to oscillatory motion. Oscillatory motion. What is oscillatory motion, sir? So oscillatory motions are the motion of an object when it is doing to and fro motion. To and fro motion of an object about a fixed point, that is called mean point. That is mean point or mean position, right? Is called what, sir? Is called oscillatory motion. Hope you might have understood what is oscillatory motion. Let me explain. See, spring block system. Let's say a spring is attached with a block and I'm just compressing this block by a length x and I'm allowing to releasing it. So this block will oscillate from here to left to right, right to left about this mean point. This is what's a mean position, right? Similarly, the motion of simple pendulum is also oscillatory motion. It is also doing to and fro motion about the mean point, this point, right? So again these motions are oscillatory motion, right? Now if I'm talking about SHM, simple harmonic motion, a simple harmonic motion is a part of oscillatory motion. So let me introduce SHM. When to say SHM, let me explain, sir. If I'm talking about a spring block system, let's say this is the spring and a spring of a spring constant K and a block M of mass M, and this block is allowed to I'm just compressing this block with with some force. Let's say with some force I compressed by an compression X. So after releasing it, it will go back and it will come to mean, and then again it will go back and again it will come to mean. It will do continuously this SHM. Now what is the condition of SHM? Can you observe it here? If I compressed it, a spring force will act backward, and that is equal to a spring force will be acting backward, and from Hooke's law we know this spring force should be is equal to minus of kx, right? What this minus sign represents, sir, this force is acting opposite to the direction of displacement of this block, right? So here can we say this force is acting on the block of mass m. So can we apply Newton's second law of motion, m into a, that is equal to minus k x, right? So finally what we got, a is equal to minus k by m into x, right? So this is the equation you should keep in mind, right? Along with that, I want to introduce one thing, a standard equation of SHM, right? So can we write like this? A is nothing, it is d2x upon dt square, and I'm taking this side, k by m into x, that is equal to 0. Sir, now I'm trying to compare with the standard equation, right? So I'm see d2x upon dt square plus omega square x equal to 0. What is omega square x, sir? Where omega square x is nothing, it is k by m, as I'm assuming. Then omega is equal to root over k by m, and finally 2 pi by t, and that is root over k by m, and finally if I'm calculating time period, it is 2 pi root over what's the m by k. This is the equation of time period of this simple harmonic motion of the block. See what will be the time period of this block while doing motion SHM, and this is called standard equation of SHM. What is this? Standard equation of SHM. Got it? So you might have understood, right? This is what you need to keep in mind, right? Next is, if you got what is SHM, now I need to conclude something here. What is the conclusion, sir? What is the condition of SHM? Conditions of SHM. Motion is SHM. How to conclude, sir? First condition is, understand, first condition of this is this force or restoring force of the block should be directly proportional to x, or you can just say, keep in mind, it should be directly proportional to minus of x actually. Why minus, sir? Or wait a second, you can just write x now, or you can say acceleration is directly proportional to x. And the second thing is, it should be negative. The force, the restoring force should act opposite to the direction of displacement. If displacement is positive, F will be negative, sir, right? These two conditions are necessary and sufficient conditions, sir. Sir, can we write like this here? Actually, above equation, if I am writing again, sir, A was equal to minus of omega square x, or you can say F restoring was equal to minus of kx. If these two things are given, the body must be doing SHM. Got it? So hope you might have understood this. I'm just, because this is just a first session, so I'll wrap it up here. It's rest thing we'll discuss tomorrow, and definitely I'll continue this series of videos and with the quality content, and I hope you will find very beneficial for upcoming sessions. Yeah, I have very shortage of time, that's why I'm not giving much time, but yeah, definitely I'll keep my time for you people, and please show your love, and definitely I will upload the videos continuously. Definitely. Thank you so much. Thank you.